Alright, here's another example of solving a system using elimination. Now hopefully at this point you're getting comfortable with the idea of making sure everything's lined up. You have your x's lined up, your y's lined up, your equal sign, and your numbers are lined up. So from there we need to start checking for opposite coefficients. First thing to look at x. 5 and 3. There's nothing that we're going to be able to do there, or rather, there is something, but nothing easily. Like we can't take 3 and multiply it by 2 to get 5. So if you look at y, is there something you can do to 2 to make it 7? Like 2 times 4 would give you 8, 2 times 3 would give you 6. So no, there's no whole number that we can multiply by 2 to make it 7. So we don't really have a set of compatible numbers here. When you have this situation, here's the easiest thing to do. Simply make a choice, whether you want to eliminate x or y. It really doesn't matter which one you want to do, just make a choice. For this one, I'm going to choose to eliminate x. So I'm going to put both of these equations in parentheses, and I'm going to do the following. The two coefficients on x right now are 5 and 3. So in order to eliminate them, I'm going to flip them and write them in front. What I mean by that is, the bottom coefficient was a 3, so I'm not going to write that on the top. The top coefficient was a 5, so I'm not going to write that on the bottom. Doing this, when I do 3 times 5x, I'll get 15x. Do 5 times 3x, I'll get 15x. So those two things are going to match now, but they're not opposite yet. So when you're doing this method of just taking the first two coefficients and flipping them, if your original two coefficients, if this 5 here and this 3 here are the same sign, meaning they're both positive, you just have to make one of your numbers on the outside negative. We'll make the bottom one negative. It doesn't really matter. I could have made the 3 negative. You'll get the same answer in the end. Your work would just look a little bit different. So as you start distributing through, you'll get 15x plus 6y equals negative 3. Negative 15x, okay, so you can see we now have a set of opposite coefficients. Minus 35y equals negative 55. And then we're now to elimination. We're going to set the problem up, start adding down our columns. Our x's go away. We are left with negative 29y equals negative 58. And now it's just algebra, two-step equation. Go ahead and divide, get your y value of 2. Take that y value of 2, plug it back into one of the original equations, top or bottom, it really doesn't matter. We'll just plug it into the y value for the top. So we have 5x plus 2y equals negative 1. Our y value is 2, so it's 5x plus 2 times 2 equals negative 1. Do some more algebra. Multi-step equation, or even just a two-step equation at this point. You get 5x equals negative 5. Divide by 5, and you'll get your x value equal to negative 1. As always, since it's a system, write your answer as an ordered pair, negative 1, comma 2. Again, we were able to do this because all we did is decide that we wanted to eliminate x. So we took the first two coefficients on x, flipped them, and then made one negative. That will always work with elimination.